Bismillah ar-Rahman ar-Rahim. Let's look at this question. Determine the force in each member of the truss. So this is the truss. You can see that there is a pin here, pin A, that there is one in the Y, there's a reaction in the Y and the reaction in the X, 1.5 meter here, and there is a force here at this joint D, 3 kilonewton. And look at this force, 4 kilonewton at point P, 2 meter, 2 meter. And look at this ruler. Look at this ruler. This ruler is not in the y-x axis. It is with an angle. So there is a force here, only one force for the ruler. Here there is two forces, one in the x, one in the y. But this ruler, look at this. There is one force in perpendicular, normal force. And always the ruler has only one force. But since this force is with an angle, you have to make it like this. Okay, so this ruler will have one reaction that way, and you know that this is you have to redistribute the loading right now. You should assume that AX that way and AY that way. If the AX answer is negative, then you should take it the other way. So let's just take it like this, AX and AY like that. This is given 4 kilonewton, and this is the normal force. Again, it is with an angle, because the ruler is with an angle, and look at the angle, theta. And he put theta is equal to 30, so he put theta is equal to 30 degrees. And he wants the force for each one of them. Let's look at this. First of all, we have to take the whole truss. We have to take the whole truss. How many unknowns for the whole truss? We have 1, 2, and we have 3. Everything else is known. So for the whole truss, we should take moment at point A. We should take moment at point A to cancel out AX and AY. Moment at point A, we could find NC. Remember, when you take moment at point A, this normal force would be 1 in the y-axis, n cosine 30, okay? And 1 in the x-axis, n sine 30. The n sine 30 is in the same line of action of A, so it will cancel out. Don't take it into consideration. So, let's find out, first of all, summation of forces in the x-axis. Okay, we have AX in the negative, so it's minus AX. And we have this one also in the negative, minus NC sine 30. And of course we have 3 kilonewton in the positive. So here we have two unknowns, AX and NC. So let's call this one reaction 1. Let's do summation of forces in the Y. We have AY in the positive. We have 4 in the negative. This is not, this is in the X. And we have this one, NC cosine 30 in the positive. NC cosine 30. Now we have AY and we have NC. So we have two unknowns. So this is, we call it reaction number 2. Because, equation number 2. Okay? So now we take moment at point A, because there is here two unknowns and one equation, and two unknowns and one equation. So we have to do summation moment at A, and from this you could find NC cosine 30 times, of course, 4 meters. And 3, it's going to take it like a negative. And 3, what's this distance? 1.5 meter minus 3. And also 4, we'll take it like this, minus 4 times 2. So we put it all. Now here, from the summation moment at A, of course, why I take summation moment at A? Because I want to cancel out these two together, AX and AY. So I'll have only one unknown. From this, you could find that NC is equal, normal force at point C, the reaction at the ruler, is equal to 3.608 kilonewton. Everything else is in kilonewton, so you put this one as kilonewton. Okay? Now, so we find NC. So we find NC. You could put this NC here. You could find from equation number 1, AX. AX is equal to 1.196. And now here we have NC for equation 2. You could find AY, 0.875 kilonewton. So now we have AX, AY, NC. Now we take, there's two methods to solve this. Either by section or by joint. Let's find bisection. Let's take the first joint. Let's take joint C. Let's take joint C. So joint C, there is how many forces on it? This force, NC, and of course NC is known. And we have CD. Remember, CD has the dimensions and the angle for the CD is 2 in the X and 1.5 in the Y. So we'll make this joint C. There's this normal reaction. Of course, the angle is 30 degrees. Remember the 30 degrees? NC, 30 degrees with the Y. So 30 degrees with the Y. This is 3.608. And of course, CD, remember 2, 1.5. 2, 1.5. And of course, 2 square plus 1.5 square, all under the square root. This is 2.5. So this is 2.5 here. And this is CD. And of course, we have another force, CP. You have CB. So CB, CD, and NC. These are the only 3 forces at joint C. If you take a joint, the only things you take into consideration is only summation of forces, no moment. So in joint, you take only summation of forces. So let's do summation of forces at the X equal to 0. So here, 3.608 cosine 30 in the minus. This is summation of forces in the X. No. Summation of forces in the X. This is cosine 30 in the Y. So 3.608 sine 30 in the negative. And of course you have CD. Remember in the X is 2 over 2.5. 2 over 2.5. And CD is in the negative. And plus CB is in L to the negative. So here we have 2 unknowns, CB and CD. So equal to 0. We could make it equation number 3. Since we have equation number 1, 2. And we could call this one equation number 3 because we have 2 unknowns and 1 equation. Let's do summation of force at the Y equal to 0. We have 3.608 cosine 30 in the positive. And we have this one, CD 1.5 over 2.5. CD 1.5 over 2.5. Now from this equation, there's only one unknown and one equation. You could find CD. So rearrange the equation, CD is equal minus 5.21. Aha. So I'm assuming, look at the CD. I'm pulling the joint, so it's tension. But the answer was negative, which means that our assumption was wrong. So it should be compression. So the answer CD is 5.21 kilonewton compression, C. Now, we should put, since we assume it tension, let's put CD here minus, okay? Because the compression is the corrected one. So we should put minus 5.21 here instead of CD to find out CB. So we put minus 5.21, you could find CB. CB is equal to 2.364. It's plus this time, so our assumption was tension. It is still tension, 2.364. So now we found CB. Now we found CB, CD and CB. Now, what is next? Let's take joint A. Joint A, remember we have AY, AX, and we have AD, and we have AB. Remember AD, the angles are 2 and 1.5. So let's solve it for the other one. Let's take joint A. We have AD, remember the angles 2, 1.5 and 2.5. And we have force AB. Remember AB? AB. And of course there is AX 1.196. Remember we found AX from the previous one. Remember we found AX from the previous one. AX 1.196 kilonewton and AY 0.875 kilonewton. So AY is 0.875 kilonewton and AX is 1.196. So now, and of course we have everything else here. According to joint method, the only 2 equations is summation of forces at x equal to 0 and summation of forces of y equal to 0. So let's find summation of forces at x equal to 0. AB minus 1.196 plus AD 2 over 2.5. So we have 2 unknowns and 1 equation. Let's go for the next one. Summation of forces of y equal to 0. AD 1.5 over 2.5 XX plus 0.875 equal to 0. Now we can find AD from summation force of Y equal to 0. So AD is equal minus 1.46 kilonewton. Now, this is AD. And AD we are assuming is tension, but since it's negative, so it's going to be AD is equal to 1.46 kilonewton compression. Since we found AD, we put it here. But what we put here is not the plus, but the negative. This is what we found. Because we assume tension, and this is also assuming AD is tension. So we put minus 1.46 here. And we get AB equal 2.36, and it's plus, so it's tension right away. So now, we found AD and AB, and we found DC and CB. So what's remaining? BD. BD should take joint B. Joint B. Let's take the last joint, joint B. There's BD, and we want to find right now. There's this one, BA, 2.364. We have it AB, 2.364, and it's tension. So assume it's tension. And we have also here, it's BC from the previous one, 2.364, it's tension. And we have also 4 kilonewton down. Okay, so now from this we could find only, you don't have to find summation of forces at x equal to 0 because we don't care about this. We care about BD. So find summation of forces at the y equal to 0. BD is equal to 4 kilonewton. So summation of force of y, BD is equal to 4 kilonewton. And since you assume it's tension and it's plus, so it's tension.